Hello learners, here's a quick challenge. If you push a box across a floor with a force of 1 Newton for a distance of 1 meter, how do we express the work done? The answer lies in a unit. Just like we use kilograms for mass and meters for distance, we need a unit for work. And in physics, that unit is called the joule. So today, we're going to talk about how work is measured, what different units are used, and how they relate to each other. Let's get started. Let's begin with the most commonly used unit, the joule. It is the SI unit of work, and we write it as capital J. Now let's define it properly. We know the basic formula for work is work equals force multiplied by displacement, or in symbols, W equals F into S. So, 1 joule of work is said to be done when a force of 1 Newton displaces a body through 1 meter in the direction of the force. In other words, 1 joule equals 1 Newton times 1 meter. This is the standard definition of work in the SI system. Now, in many real-life applications, like electric generators or engines, the amount of work is much larger than 1 joule. So we use bigger units for convenience. 1 kilojoule equals 10 to the power 3 joules. 1 megajoule equals 10 to the power 6 joules. 1 gigajoule equals 10 to the power 9 joules. For example, an electric heater that consumes 1,000 watts of power for 1 second does 1 kilojoule of work. So these larger units are very useful in industrial and energy-related calculations. Now let's switch gears and look at another system, the C.G.S. system, or centimeter grams second system. Here, the unit of work is called the erg. So what is 1 erg? By definition, 1 erg is the work done when a force of 1 dyne displaces a body through 1 centimeter in the direction of the force. Mathematically, 1 erg equals 1 dyne into 1 centimeter. This unit is used when we're working with very small forces or displacements, such as in atomic or microscopic physics. So while the joule is used in large-scale systems, the erg is handy for the tiny scale. So how do we convert between joule and erg? Let's derive this step by step. We already know 1 Newton equals 10 to the power 5 dyne. 1 meter equals 10 to the power 2 centimeters. So, 1 joule equals 1 Newton into 1 meter is equals 10 to the power 5 dyne times 10 to the power 2 centimeters is equals 10 to the power 7 dyne centimeters is equals 10 to the power 7 erg. Hence, 1 joule equals 10 million erg. Or in scientific terms, 1 joule equals 10 to the power 7 erg. This is a very important relationship, especially when switching between unit systems in exams. Let's quickly recap what we've learned about the units of work. The SI unit of work is the joule, written as capital J. 1 joule is the work done when a force of 1 Newton moves a body by 1 meter in the direction of force. For larger quantities, we use kilojoule, megajoule, and gigajoule. In the C.G.S. system, the unit is erg, where 1 erg equals 1 dyne into 1 centimeter conversion formula. 1 joule equals 10 to the power 7 erg. So next time you read about the energy in an earthquake or the battery of a mobile phone, check which unit of work is being used. And now, you'll understand exactly what it means. I hope this session gave you a clear and confident understanding of how work is measured in physics. See you in the next session, where we'll explore power, the rate at which work is done. Until then, stay curious and keep calculating.